So we'll get started right now with our first opportunity, which is the Via 57 West project. Via 57 West is a one-of-a-kind apartment building. It's owned and maintained by the Durst Corporation. Douglas Durst decided against building a condo tower back in 2010 because of the poor physical occupancy rate that had become a reality in New York around that time. Back then, condos were primarily being bought by foreign entities as assets, and as a result of only a few people actually using the building as a primary residence, the commercial spaces on the ground floors were failing. Rental apartments in Manhattan had also become quite scarce, so the rental concept proposed by Durst provided an obvious solution. When the 709 apartments at Via 57 West first became available for rent in 2015, the price ranged from as low as $569 a month for a studio unit to $843 a month for a 3-bedroom unit. Very cheap living for Manhattan, that's for sure. Douglas Durst, he first met architect Bjork Ingels in the early 2000s. He was visiting Copenhagen with his wife, Suzanne, who's a native of Denmark. And now we fast forward to the spring of 2010, and Durst commissions Bjork to bring a new residential typology to a plot of land just off the West Side Highway in Manhattan. Durst's one request was that it wouldn't block the view of the tower behind it, which was also a Durst property and one of Douglas's private residences. Bjork and his team ran a series of computer-generated models to design a building that maximized the view for the tower behind it. So you can see here in this example, this is the tower that Durst owned originally, and you can see how they designed the building to fill maximum usage of that plot of land while also leaving as many views possible remaining for that tower behind it. And here's the view they were trying to preserve. And because of the building shape and all of the metal panels that would make up its facade, cleanability was vital to the owner and the design team. Stainless steel was an obvious choice for sustainability since Durst would go on to own this building long term, but they had concerns about the stainless steel facade appearing dirty over time. And this is probably why. This is the Saucony Mobile building in New York City. It was built in 1956 using deep embossed panels made from stainless steel with a number 4 finish. This is a picture of it being cleaned in 1997. Cleaning was mostly done with cotton cloth, soap, and water. The nature of the abraded number 4 finish acted as a trap for dirt and contaminants, and although after many years it was easily cleaned off, the use of a microtexture finish back in 1956 would have created a surface environment that would have easily shed those contaminants away naturally as opposed to trapping them. So finally, after a long vetting process, they selected Enviromat microtexture because of its low glare and naturally cleaning properties. Cleanability is all about surface tension. Water, much like dirt, does not like low energy surfaces like Enviromat, making them less likely to retain dirt particles and thus easier to clean since anything that does settle on the surface is not bound in any way and can easily be released. You can see here in this example, this bead of water on the Enviromat fits very nicely. It looks a lot like a bubble of water that's sitting on a freshly waxed car. Not the case with the number 4 satin. In the next slide, we'll explain a little bit of why that is. In this illustration, you can see the number 4 finish has grosser irregularities and provides varying angles to help increase the wetting and thus trap more dirt as a result. The microtexture illustrated above is much smoother. It does not break the surface tension of the water, never letting the water wet the surface of the microtexture, so dirt will shed more easily. So a little bit better example, you can see now how this bubble of water is allowed to sit on top of the surface, and here the gross irregularities are causing penetration into the surface tension of the water, allowing it to wet the surface, bringing with it dirt and contaminants that are now be trapped. Now that a finish was selected, we began shipping precision laser cut sheets of Type 316 Enviromat enclosed to begin assembling the facade modules. No 2 sheets were the same, and much attention was given to coordinating accurate packing lists to assist the assembly process over at Enclose. The modules were fabricated off-site in Richmond, Virginia, from a complex arrangement of aluminum extrusions, brackets, clips, thermal insulation, waterproofing, and finally the Enviromat exterior surface, which was essentially a precisely cut flat piece of Enviromat that was draped over a curved form. Each facade module was matched to a curved steel support frame, which was pre-installed onto the building prior to delivery of the facade module. As you can see in this picture here, these were basically brought in from a third-party vendor, built to spec. They would then test those specs in Richmond, Virginia. Anything that was out of spec would then be corrected using a special jig and a laser to get it as close to spec as possible prior to installing in New York City. Here you can see the steel support frames being mounted to the building's concrete core. Panels were then lifted into place with a special lifting jig that angled the panel to match its location on the curved facade. This was done to try to eliminate as much of the human element as possible, risking injury or damage to the panel. They already kind of came in at the angle of the facade, then it was just simply aligning the bolts, the holes up for the bolts. These panels were installed in layers over the facade and were fastened to the building structure from within the building. These modules created both the facade as well as the opening for the balconies of the apartments within. This view gives you a better idea of how it all comes together. And then this is a great look inside the courtyard. The idea of the residential typology that Douglas Durst was looking to bring over was this concept of community within a community. In this building, you have a movie theater, restaurants, bars, fitness centers, basketball courts. You have residences within the courtyard looking over at other residences. So you bring in this sense of community within the greater community of New York City. And that was what their entire design intent was. And you can also see New York really likes to work with natural metals. And this picture of the building topping off shows a lot of the reason why. You really get to see that natural metallic reflectance that you just can't replicate with paint. And then you can see here that natural metallic reflectance illuminating the environment around it. It's one of my favorite pictures of the building. And now we're going to move on to another exterior project. This is the Hamad International Airport. In 2001, HOK specified a zinc roof for a new airport being built in Doha, Qatar, on an 8.5 square mile area of newly created land just offshore in the Persian Gulf. However, we felt they needed a much more appropriate alloy for how severe of an environment Doha has. For starters, the newly created area of the airport was made with reclaimed soil that had an extremely high iron content. Furthermore, the high salinity of the Persian Gulf, extreme heat and humidity, as well as the mere 2.9 inches of annual rainfall make for an extremely severe environment. Throw in downwind petrochemically processing, and you have one of the most difficult environments to try and have a successfully sustainable metal installation. You can see here, this is the reclaimed area for the airport just off Doha City. We considered titanium, but back then we were at war and the new Boeing and Airbus megajets were being constructed, so much of the titanium being produced was already allocated. With this roof requiring 4.5 million square feet of material, we had concerns that we would not be able to source enough titanium to complete the roof. With titanium out of the question, we were forced to look at stainless steel. But as you can see from these crossing swords made Type 316, they were already rusting after just a few months of being installed. So with the standard marine grade stainless ruled out, we needed to find a more noble alloy that could withstand these severe conditions. We then considered a duplex alloy like 2205, but with all the skylights on the roof that would require field welding, and with all the embrittlement issues associated with field welding 2205, we were forced to rule the duplex alloy out. We finally settled on a lean duplex alloy called ATI 2003, which was developed for offshore oil rigs and could easily be welded in the field and would hold up to the severe environment of Doha. The Enviromat finish was then selected because its low glare finish would not blind pilots on approach, a major concern for this desert airport. A lean duplex alloy like ATI 2003 works by confusing any corrosion that may occur from prolonged degradation. The metallurgical structure consists of austenite and ferrite in roughly equal portions. So should corrosion attack a grain of austenite, it would be snuffed out when it ran into a grain of ferrite, and vice versa. because corrosion cannot recalibrate on the fly and attack different grain structures. As you can see from this diagram, the light shapes are representative of austenite, the dark of ferrite. The idea is if corrosion were to occur, it occurs on a microscopic level, thus not compromising the overall integrity of the alloy. Because of the low thermal coefficient of expansion in stainless steel, some sections of roof consist of some of the longest sections of continuously run panels ever done. Some panels on the main terminal measured as long as 480 feet. Now these panels here, probably around 180 to 220 feet. The idea is just kind of give you an idea of scope of how long some of these were. The panels were roll formed on site and hoisted on the roof by crane. They were then staged on the roof prior to installation. You can see the nice tight tolerances we were able to keep. That was something of a concern working with the high spring back rate of stainless steel and the high tensile strength of the duplex alloy. So as you can see, they were able to keep it in check exactly where they needed to. Now this slide tells a very interesting story. Not only does it show how little glare the Enviramat finish is producing, but the men in the photo were amazed by how on a 120-degree day, their shoes weren't melting on the stainless steel, and they could even touch the bare metal without burning their fingertips. They came back to the US with the goal of finding out exactly why that was. Sure, there were studies on the SRI level of painted aluminum, but a study had not yet been done on stainless steel. We studied 3 popular building materials after a 20-year life cycle, and we found that the stainless steel actually performed the best by retaining a high reflectance rate of around 94%. White paint starts out very good with a reflectance rate in the 90s, but after degradation, it ends up only directly reflecting about 60% of the sun back into the atmosphere. Of the total infrared radiation that each building material emitted, about half was absorbed by the building, and the other half lingers in the surrounding air, contributing to the heat island effect. And what we're demonstrating in this slide here, the yellow lines are the sun's rays directly going back into the atmosphere. The red representative of the infrared heat that is either contributing to the heat island effect or being brought into the building and have to be remedied by the HVAC components. The stainless steel roof we tested was on the Enviramat clad roof of the Pittsburgh Convention Center, one of the first LEED green buildings ever completed. The management continues to report that the convention center has heating and cooling bills that are far less than they ever expected. We suspect the stainless steel roof has a lot to do with that. Currently, the Enviramat stainless steel roof on the Hamad International Airport is the largest in the world, and after all the expansion work is eventually completed, the airport will be able to handle up to 93 million passengers per year, making it the second largest airport in the region after Dubai. The check-in and retail areas are expected to expand to 12 times their current size, making the whole airport roughly 2/3 the size of Doha City. So the expansion is going to come here off the end of the tail wings. They're going to expand the belly out even more so they could fit in more retail in the terminal area. And now we're going to move on to our final exterior project. This is the city center at Bishop's Ranch, which was designed by Renzo Piano back in 2015. Renzo needed to clad the parking structure above the mixed-use facility, which consisted of office space, restaurants, and high-end retail. This new complex was located in the high-rent area of San Ramon, California, so the parking ramp cladding, which was a feature aspect of the complex, needed to be aesthetically pleasing as well as sustainable. As is typical with parking ramp construction, the budget was fairly limited and they were struggling to find an affordable high-end solution. Eventually, they contacted Century about their Econolab system to see if they would be willing to incorporate a stainless steel finish such as our Enveratone into it. This came as some surprise to Century as their Econolab system is their entry-level cladding offering and is made up of a combination of corrugated panels attached with exposed through-wall fasteners. So the question of if the system would be compatible with a high-end product like stainless steel had honestly never been considered before. Century performed a trial with our Enveratone stainless steel and found that it was very easy to incorporate into their Econolab panel profile. When we did our testing, we tested the corrugation panel, which we had no issues with. The main concern they had were on these curves that bend at a 90 degrees. You're bending a corrugated panel, which they were concerned the springback rate of the stainless steel might be too great and their tooling wouldn't be set up to get that. But we were able to accommodate it very easily and found, in fact, they were set up to run stainless steel, which opened them up to a whole new opportunity in the high-end metals world with this system. In the end, what we found was that for a very reasonable price, they were able to clad the parking structure with the high-end material and achieve the original design intent. And this is why we like this example so much, because it shows that the material selection can make all the difference in the world. And by using high-end materials in a low-budget system, the opportunity for stainless steel cladding becomes much more realistic. And this concludes the exterior portion of our